differential equations that are reducible to exact form. Okay, so what this means is that these differential equations are not exact. They're not exact, but what we can do is we can rewrite them or somehow make them exact. Now, the way we do that is by introducing what we call an integration factor. So this integration factor is something you can multiply the differential equation with, and then after you do that, your differential equation will become exact. So we look at examples of such differential equations and then how we actually find this integration factor. So for example, we have number 1. This is xy dy is equal to 0. Okay, so here we have our p is x squared plus y squared, and then q is xy. So we want to check and see, is this exact? You can see this dp, dy, this is 2y, and then dq, dx, this is x. So clearly these two are not equal, so this differential equation is not exact, but we can find the exact differential, we can find the integration factor that we multiply by to make our differential equation exact. Now there are a few steps that we have to follow in order to find this integration factor. The first one is to determine delta. Okay, delta is given by dp dy minus dq dx. Okay, so that is how we determine delta. So we've already worked out dp dy and dq dy. So here in our case, delta is going to be 2y minus y. And we have delta is equal to y. Now, if now from here, the second step, what we do is we are going to divide this, I'm writing d instead of delta, delta here. Okay, now what the next step after you determine delta, this is the formula for determining delta. The second step is you will divide delta by q. So step number 2b, determine delta divided by q. So here my delta is y, and then I'm going to divide it by q, which is xy. So delta over q, this is y over xy, which is just 1 over x. Okay, so now I have my delta over q. You ask yourself two things. The first one is, if delta over q is not a function of x only. First, let's start with if it is a function of x only. If delta is a function of x only, so that means it only contains x, there's no y in the formula like we have over here, then our integration factor, call it IF, denoted with R, this is equal to e to the power of delta over q dx. So this is e, and the exponent of e is the integral of this function that you have over here. And then the second case is if delta over q is not a function of x only. So that means it contains y of x only. Then find dp. So instead of dividing delta with q, we try delta with p. And then from there, we say if delta over p is a function of y only, then the integration factor r will be given by e to the power of minus the integral of delta over p dy. Okay, so those are the two possibilities. The first one, you divide delta over q, you look at the function that you end up with. If it is a function of x only, then what you do is you find your integration factor, e to the power of the integral of this function you worked out here with respect to x. But now if this function here that we get is not a function of x only, so maybe it includes x and y terms, then we need to divide delta by p. And then if the function is a function of y only, then our integration factor is found in this way. Okay, so we continue with our example that we're looking at. We found delta, which was y, and then we divided by q first. We see that we get 1 over x. 1 over x is a function of x only. There's no y, so we are here, case number 1. So we determine our integration factor. This is e to the power of the integral of 1 over x dx. This is e to the power of ln of x. With your integration factor, you don't add a constant. We are just interested in the function part. All constants are gone. And then this is x. Okay, so e to the power of ln of x is equal to x. Now what we do with this integration factor is we will then multiply our differential equation over here, the one that was not exact, and after we multiply it by the integration factor, we should now have a differential equation that is exact. Okay. So when we multiply it, we have x multiplied by x squared plus y squared dx plus x squared y dy. This is 0. So this is x to the power of 3 plus x y squared dx plus x squared y dy is equal to 0. Okay, then we can check and see, is what we have now exact? Okay, so doing that, we have our p, which is x to the power of 3 plus x y squared, and q is x squared y. So dp dy, this is 2xy, and dq dx, this is 2xy. So now we can see that these two are equal, so our differential equation is exact. And now that we know that it is exact, we proceed to solve it as an exact differential equation. So that means we can integrate p with respect to x or q with respect to y. I'm going to integrate this one just because it has only one term and this one has two terms, so it's easier to integrate that one. So our function f will look like this, the integral of q with respect to y, which is equal to the integral of x squared y dy, and this is x squared y squared divided by 2, and then we add a function of x. Then the next step is differentiate with respect to x. This is x y squared plus f prime of x, and remember this must be equal to p. So p is x cubed plus x y squared. So I have x squared x y squared plus f prime of x. This is equal to my p here, x to the power of 3 plus x y squared. Okay, so these two will cancel, and then you can see I have f prime of x is equal to x to the power of 3. Yeah. And then we work out f of x. This is 3 x to the power of 4 over 4 plus my constant. And then my solution will be x squared y squared divided by 2, and then I add f of x and equate that to c. So what I will have is x squared y squared over 2. So I have x squared y squared over 2. Then I add my f of x, which is x to the power 4 over 4. And this is equal to c. So again, we can multiply out the denominators. So we have 2x squared y squared plus x to the power of 4 is equal to c. Okay. Another example, we have to solve this differential equation, 3x squared plus y squared dx minus 2xy dy, so is equal to 0. So our p here, this is 3x squared plus y squared, and our q is negative 2xy. So we can differentiate each of them and see if they are equal, then we'll know if it's exact or not. So we have dp dy, this is 2y, and dq dx, this is minus 2y. So clearly these two are not equal, so it's not exact. So we need to see if we can find an integration factor. So the first thing we do is we work out delta. Delta, we said this is dp dy minus dq dx. So this is 2y minus negative 2y. We have 2y minus negative 2y, which is 4y. So then we have our delta, and then we say delta divided by q. This is 4y. We divide it by q, which is that one, negative 2xy. Negative 2xy, which is 2 negative 2 over x. Okay, so after we work out d delta over q, we ask ourselves, is this a function of x only? Yes, it is. So our integration factor r is going to be e to the power of the integral of negative 2 over x dx. So this is e to the power of minus 2 ln of x. Remember, we don't include the constant of integration when we're finding our integration factor, and this is 1 over x squared. Okay, so now we have our integration factor. What we do is we multiply the differential equation by the integration factor. So I have 1 over x squared here, 1 over x squared there, and then what I should have after that should be exact. So what I will have is 1 over x squared. I multiply that by p, which is 3x squared plus y squared dx, and then minus 1 over x squared 2xy dy. This is equal to 0. So this gives us 3 plus y squared over x squared dx, then minus y over x. dy, this is 0. So now our p is 3 plus y squared over x squared, and our q is negative y over x. Okay, so we have to differentiate each of these. Sorry, negative 2. The 2 should still be there, that 2 there. Okay, so now we will differentiate p with respect to y and q with respect to x and see if our values are the same. So we find dp dy. So differentiating this with respect to y, we just get 2y over x squared, and then dq dx, and this is 2y divided by x squared, and then this negative will multiply by the negative 1, which is the exponent of x right now, and that will make it positive. So this is 2y over x squared. So the two derivatives are equal, so our differential equation is now exact. So now that we have an exact differential equation, we proceed as we have always done. Either you will integrate p with respect to x or q with respect to y. So here again, I think it's easier to integrate q with respect to y than that one. Not that much easier, but Anyway, that's my preference. So our function f, we will say this is the integral of q dy. This is the integral of minus 2y over x dy. And this is equal to minus y squared over x. And then we add a function of x. There we differentiate f with respect to x. This gives us y squared over x squared, and then our function f prime of x. And remember, this must be equal to p. So we have y squared over x squared plus f prime of x. This is equal to p, which is 3 plus y squared over x squared. Then those two will cancel. So we have f prime of x is equal to 3. And then this means f of x is the integral of 3 dx. And therefore f of x is equal to 3x plus c. Okay, then our final answer will be this part here, plus 3x is equal to c. So the solution will be 3x minus y squared over x. This is equal to some constant c. Another one, y squared plus 2 dx, 3xy plus 2x over y dy. This is equal to 0. Okay, we check and see if this is in fact exact, but obviously we expect that it is not. Okay, so dp dy, this is 2y, dq dx, this is 3y, plus 2 over y. Okay, so what we do is we work out, excuse me, we work out our integration factor because these two are not equal. So we find delta, which is dp dy minus dq dx, which is 2y minus 3y plus 2 over y. So this is minus y minus 2 over y. Okay, then we say delta divided by q. This is minus y minus 2 over y. This is divided by 3xy plus 2x over y. Okay, so no matter how we simplify this, I think this will always contain x and y terms. Let's see. Let's simplify this. Okay, this is negative, and then I have y squared minus 2 over y. This is divided by 3x y squared plus 2x over y, and this is equal to, sorry, this is a plus here. This is y squared plus 2 over 3x y squared plus 2x. Okay, so this is definitely not a function of x only. So now we need to try and divide delta by p and see if we will get something that is a function of x, of y only. So now we say delta over p. Our delta was negative y minus 2 over y. So this is negative y minus 2 over y. And then we divide by p, which is y squared plus 2. Okay, so this one contains only y. So this is a function of y only. And therefore, we can work out the integration factor. So let's simplify it first because we need to integrate this whole term here, e to the power of the integral of this. So we have negative, our numerator, we have y squared plus 2 over y. Then in the denominator, we have y squared plus 2. So this is negative y squared plus 2 over y divided by y squared plus 2. Our division will change to multiplication, and then you have the reciprocal. This is negative y squared plus 2 over y times 1 over y squared plus 2. You can see that those two cancel. I have negative 1 over y. Okay, now I work out my integration factor. R is equal to e to the power of, and because this time I divided by p, this is negative the integral of delta over p, which is minus 1 over y dy. So this is just e to the power of the integral of 1 over y dy, which is e to the power of ln of y, which is y. Okay, so now I have my integration factor. I'm going to multiply the differential equation by that integration factor. For doing that, we have y multiplied by y squared plus 2 dx, y times 3xy plus 2x over y dy. This is 0. We have y cubed plus 2y dx, 3x y squared plus 2x dy is 0. Our p is y to the power of 3 plus 2y. Our q is 3x y squared plus 2x. And dp dy, this is 3y squared plus 2. And dq dx, this is 3y squared plus 2. So these two are equal. So now our differential equation is exact. And then we choose which one to integrate. So I think integrating this with respect to x is easier than that one with respect to y. So my function f will be the integral of p dx, which is the integral of y cubed plus 2y dx. This is x, y to the power of 3 plus 2x y, and then I add my function of y. Differentiate this with respect to y. We get 3xy squared plus 2x plus f prime of y, and this must be equal to q, which is 3xy squared plus 2x. So 3xy squared, 3xy squared, 2x, 2x. So we can see that f prime of y is equal to 0. This means that f of y is a constant. So our solution will be xy cubed plus 2xy is equal to c. So we have xy cubed plus 2xy is equal to some constant. Okay. And looking at some of the questions from the exercise, look at the first one. 5x cubed plus 3xy dx plus 3x squared plus 2xy cubed dy is 0. Our p, 5x cubed plus 3xy q, 3x squared plus 2xy cubed dp dy. This is 3x dq dx. This is 6x minus, no, plus 2y cubed. Okay, so obviously this is not exact, so we find delta dp dy minus dq dx. This is 3x minus 6x plus 2y cubed, and this is equal to negative 3x minus 2y to the power of 3. Then we have to divide delta by q. So delta divided by q, this is negative 3xy minus 2y cubed. Divide this by q, which is 3x squared plus 2xy cubed. Okay, so we see that in the sorry, this y here is not there. There's no y there. Okay, so we see that in the denominator, if we factor out a y, then sorry, not a y, an x in the denominator, then the numerator and denominator can cancel. Again, this is also a plus. Yeah, I think now it's right. So this is negative 3x plus 2y cubed over x with 3x plus 2y cubed. Okay, then those two will cancel, and then I have negative 1 over x. Now our delta over q is a function of x only, so our integration factor r is going to be e to the power of the integral of 1. It's negative because that's what we got there. Dx, which is e to the power of minus ln of x, which is 1 over x. So we multiply everything by 1 over x. So we have 1 over x multiplied by 5x to the power of 3 plus 3xy dx plus 1 over x, 3x squared plus 2xy to the power of 3 dy. This is 0, and this leaves us with 5x squared plus 3y dx plus 3x plus 2y to the power of 3 dy. This is 0. Okay, so again, check that this is in fact exact, showing that you've worked out your integration factor correctly. Okay, then dp dy, this is 3, dq dx, this is also 3, and these two are equal, so we do have an exact differential equation. So now you have to decide whether you'll integrate this with respect to x or this with respect to y. They look equally complicated. So to find my f, I will integrate p with respect to x. This is the integral of 5x squared plus 3y dx, which is 5x to the power of 3 over 3 plus 2xy, and then you add your function of y. You differentiate with respect to y, you will get 0, 2x plus f prime of y, and this must be equal to q. Okay, what is my q? Let me just see here what I did. This plus 3, then this will be 3. Okay, now it's fine. And this is equal to 3x plus 2y to the power of 3. So the 3x will cancel, and then we have y prime, f prime of y. This is equal to 2y to the power of 3. Okay, then this means f of y is equal to 2y to the power of 4 divided by 4 plus c. So f of y is equal to y to the power of 4 plus c. Okay, then our solution will be 5x cubed over 3 plus 3xy. So we have 5x cubed over 3 plus 3xy, and then we add our f of y, and this is equal to c. And we can multiply everything by, by 6, just to make it look nicer. And here we will get 10 x to the power of 3 plus 18 xy plus 3 we have 3 y to the power of 4 is equal to c. Okay, so that is our solution. Okay, let's see another one. Which one? Okay, number 3. Four x cubed y cubed plus 6 x to the power of 5 y dx plus 5 x to the power of 4 y squared plus 3 x to the power of 6 dy. This is equal to 0. So my p here is 4 x to the power of 3 y cubed plus 6 x to the power of 5 y, and then q is 5 x to the power of 4 y squared plus 3 x to the power of 6. So we find dp dy. This is 12 x to the power of 3 y squared plus 6 x to the power of 5. Then dq dx. This is 20 x to the power of 3 y squared plus 18 x to the power of 5. So obviously this is not exact, so what we need to do is work out our delta. Delta will be dp dy minus dq dx. This is 12 x to the power of 3 y squared plus 6 x to the power of 5, 20 x to the power of 3 y squared plus 18 x to the power of 5. So we have 12 minus 20, that's minus 8 cubed y squared, and then 6 minus 18, this is minus 12 x to the power of 5. Then delta over q, this is minus 8 x cubed y squared minus 12 x to the power of 5. Divide this by our q over here. We have 5 x to the power of 4 y squared plus 3 x to the power of 6. Okay, so we can try factorizing, but we will not be able to change it. Let's see if we take out negative 2 here, then we have 4 and 3, but here we will have 5 and 3, so they won't be able to cancel. So even if we take an x out here in the denominator, the coefficients of the terms will not cancel or will not be the same. So this is not a function of x only. So we have to try delta over p. So delta over p, this is equal to minus 8x cubed y squared minus 12x to the power of 5 divided by 4x cubed y cubed plus 6x to the power of 5y. Now in the numerator, we can factor out -2. So we take out -2, we have 4x y squared minus, no, not minus now, it's plus 6 x to the power of 5. And then in the denominator, if we take out x, we will have 4x squared y. This is power of 3. So in the denominator, we should take out y. So we take out y, so it's x to the power of 3, y to the power of 2, and then 6x to the power of 5. Okay, now these two can cancel, and we have -2 over y, which is a function of y only. So our integrating factor will be e to the power of -2 over y, which is e2 1 over y dy, which is e2 ln of x, which is x squared. Okay, then we multiply everything by our integration factor. So we will get 4x cubed y to the power of 5 plus 6x to the power of 5 y to the power of 3 dx. And then we have 5x to the power of 4 y to the power of 4 plus 3 x to the power of 6 y squared dy, and this is equal to 0. So we can find dp dy. So this is our p. We integrate this with respect to y. We have 20x cubed y to the power of 4, and then 18x to the power of 5 y to the power of 2. Then dq dx, this will give 20x to the power of 3 y to the power of 4, and then we have 18x to the power of 5 y squared. So you can see that our two derivatives are equal, therefore it is exact. So this is exact. Then we can now solve it by integrating either p or q with respect to x or y, depending on which one you pick. Okay, so I'm going to integrate p. So we have 4x to the power of 3, y to the power of 5, plus 6x to the power of 5, y to the power of 3 dx. This is x to the power of 4, y to the power of 5, and x to the power of 6, y to the power of 3, plus some function of y. Then we will differentiate this with respect to y and equate it to q. So we have 5x to the power of 4, y to the power of 4, plus 3x to the power of 6, y squared, plus f prime of y. And this must be equal to q, which is 5x to the power of 4, y to the power of 4, plus 3x to the power of 6 y squared. So that, and we have f prime of y equal to 0. This means that f of y is equal to c. So our solution will be x to the power of 4, y to the power of 5, x to the power of 6, y to the power of 3 is equal to a constant. I think we can do one more. Just see. Number 5. Okay, this is 0. This means our p is 2y squared plus x squared. This is 2x y. So dp dy, this is 4y, and dq dx, this is 2y. So this is definitely not exact. So our delta dp dy dq dx 4y minus 2y, this is 2y. Then delta over q, this is 2y over 2xy, which is 1 over x. So our r, e to the power of integral of 1 over x dx, e to the power of ln of x, which is x. So multiplying everything by x, we have 2x y squared plus x to the power of 3 dx plus 2x squared y dy. This is 0. Okay, so we can check and see if this is exact. For xy, then dq dy, sorry, dx, this is for xy. So these two are equal, therefore it is exact. And I'm going to integrate this one with respect to y. So I have the integral of 2xy to x squared y dy, and this is x squared y squared plus a function of f, and integrate that with respect to x. We have 2x y squared plus f prime of x. This is equal to p, and our p is 2x y squared plus x to the power of 3. So So f prime of x is equal to x to the power of 3. And this means that f of x is equal to x to the power 4 over 4 plus our constant. So our solution is x squared y squared plus x to the power of 4 over 4. So there's a constant, and as always, you can rewrite it is equal to C. Okay, so there are more exercises in your textbook, so be sure to try them, and you will get the hang of it. I always say practice is key, so make sure that you do practice and are getting ready for the next test.